Welcome back to the Python Made Easy series. Today is dedicated to the mighty Python Lambda function. We'll cover what they are, how to use them, how to construct them, how they compare to conventional Python functions, and as always, we will be filled with examples. So what are these Python lambdas? A lambda is a one-line expression that generates function objects. A lambda expression generates a new function to be called later, but it returns the function instead of assigning it a name, as we do with conventional functions. Since it has no name, for example, like myfunc in def myfunc, a conventional function, it's known as an anonymous function. Lambdas, unlike conventional Python functions, are expressions, not statements. They can appear in places def statements can't, for example, as the argument for a conventional function call. The basic syntax for a lambda is pretty easy. First, we use the keyword lambda. That's followed by one or more arguments. That's followed by a colon, and then the expression, which will make use of those arguments. All right, ready? Here's our first lambda example. Y equals lambda x colon x plus x. So x is our one argument, and then x plus x is our expression making use of our one argument. We assign that to a variable y, and then we print y with the value of 2, and 2 will of course take the place of x, or x represents 2. You can see it that way. The output, of course, 2 plus 2 is 4. Pretty easy. And let's take a moment to see how regular Python functions compare to Python Lambda functions. On the left-hand side, we have a conventional function. We call it molt. We use the def keyword to create it, and it has two parameters, a and b. Then we return a times b. We have a variable below called caller, where we're calling the function molt. We pass it the values of 4 and 5. We print out the caller, and of course, the response is 20. Now on the right-hand side, we're going to do the same exact thing, only we're going to use the lambda expression or the lambda function. C equals lambda a comma b colon a times b. We print C with the values of 4 and 5, and we get 20. So 2 less lines of code. This would be a perfect place for us to use a lambda function rather than a conventional Python function. Okay, and here we have a lambda inside a list. In fact, we have 4 lambda expressions as elements of a list. We could not do this. We wouldn't be able to do this with a conventional function, obviously. So what do we have here? We have lambda w, then we have w plus the string man, same thing plus fan, same thing plus duper, same thing plus smart. Then we have defined w here as super, another string. And then we have a for loop for item in list 1, which is our list, print item w. So when we do that, we get this concatenation. So we get superman, superfan, super duper, super smart. So w just gets concatenated with the string in the latter part of the expression, the lambda expression. Pretty easy and pretty cool, huh? Okay, so here we have a lambda in a function. So on the left-hand side, we've defined dig, our function. It takes parameter num1. In the body, we have expo, which equals our lambda, num2 colon num1 to the power of num2, floor division 2, and then we return expo. So lambda here has its own local scope. num2 is in its local scope. However, it would also be able to make use of enclosing scope, for instance, if we had a variable defined in the body of defdig, like we do on the right-hand side, num1. So legb rules apply here as well, and anything defined in the body of dig would be our lambda's enclosing scope. So what do we do here in the caller? We define a as equal to dig. We pass it 2 as its argument. Then we have b equals a4. And of course, a is dig2. So 4 will be the value of num2, right? 2 is the value of num1. 4 is the value of num2. So we'll have 2 to the power of 4. We print it out, and we get the results 8. On the right-hand side, where we actually put num1 equals 2, num1 is in the body of our dig function. It's the enclosing scope for our lambda function. Since it's in the enclosing scope, our lambda is able to make use of it in its expression. It's the E, right? Enclosing in LEGB, the LEGB rule. So here we're going to use Lambda with some of our Python built-in functions. The first one we'll use on this slide is the map function. Map takes a function in its first position and then one or more iterables after that. It returns an iterator that applies the function to every item in the iterable, yielding the results. So we have list1 or L1 equals 222 and L2 equals 5, 10, and 20. Then we have our variable tote, which equals our map, passing it in its first position, or our lambda. We have the full lambda expression here with a and b as its variables, and then after the colon we'll multiply a times b for the expression part. Then we pass in two iterables, L1, L2. So if we were to just print tote right now, by definition, this is going to print out the map object, right? It returns an iterator. And if we look at the type of tote, it's class map. So we must do something else to extract this data. One thing we can do is convert it to a list. And we do that by using the list function. That's list underscore tote equals list tote. Pass it the output of our lambda using lambda with our map. And then we're able to print list tote, and we're able to get in list form 10, 20, and 40 as we would expect. We could also have used a for loop, as I show in the lower right-hand corner of the slide, for x in tote, print x. That's another way to do it, and we'll certainly use that way in the slides to come. And as promised, another example of using a lambda within a function, within one of Python's built-in functions. This time it's filter, and the filter function takes a function for its first argument and then one iterable. It constructs an iterator from those elements of the iterable for which the function returns true, hence the filter. It only takes those ones that return true. So we have list 3, a list of numbers 2 through 30 here, and then x equals filter lambda x colon, where x is greater than 10, comma, and we pass it list 3, our iterable, our one iterable. And here we use a for loop instead of the list constructor. So for item in x, print item, and then I do end equals empty quotes, so it prints all on one line, and we see that the results are 20, 25, 30, all those items in our list that are greater than 10. And one last example of using a lambda with a built-in Python function, and we'll use the sorted function. The sorted function takes an iterable and returns a new list from its items. And you see the syntax here. So first we have a list full of tuples. Then we have the variable a equals sorted. We pass it animals, which is our list of tuples. And then we have key equals lambda. So it's a slightly different format here. Key equals lambda x, our variable, colon. Then we pass it an x position 1, which will be the second of the 3 items in each tuple, right? So the numbers. And then we will sort reverse by true, right? Reverse equals true means that we're going to sort in the reverse order. So if I'm sorting by those numbers, without the reverse, it would be 11, 12, 13. And this way, when I do my for loop, for x and a print x, it does exactly the reverse, 13, 12, 11. So in essence, I'm printing by each dog's age in reverse order. Okay, Python family, thanks for watching till the end. If this has helped you, consider helping me to continue to bring you and others this type of content. Helping is really easy. First, subscribe to the Yogi Coder channel. Second, like this video and leave comments if you feel moved to. And third, share this on any and all social media channels with your colleagues and friends. See you next time.